Okay, friends, we need to take a few minutes. It's not going to be a long video, but we need to go over table I. So this is on your reference table. Let's take a look at the first 6 reactions written here on table I. They're right here. And you will notice that they are all some sort of organic compound plus oxygen gives you CO2 and water. And way back when we did our types of reactions, we learned that that kind of reaction is called a combustion reaction. Okay. The combustion reaction also gives you a delta H. We're just going to look at these top 6 for a second. Now you'll remember from our potential energy diagrams, when the delta H is negative, it is an exothermic reaction. An exothermic means it's giving off heat. Give off heat. Should make sense because combustion means to burn, and if we are burning something, we are giving off heat, the heat that's stored within it. So all of these top 6 ones right here, 6, that's not English, but you get the idea, are all negatively charged. They're all giving off heat. So I'm going to write this top one right here on the next page so that I have some room to write. All right, so when you look at the top of table I, you'll see this reaction, CH4, that's methane, plus 2 oxygens, and those are gas as well, and you make carbon dioxide, which is gas, and you make water, that is liquid. And you see that this delta H is a negative 890. This negative means that it is an exothermic reaction. And exothermic reactions, the heat is being released, so it is a product. And products are written on the right side of the arrow. So really, that 890.4 should be written right here on the right side of the reaction. Notice that I put a plus sign there. That plus sign means that it is releasing that 890.4 kilojoules. It's only a negative when you don't have it written in the reaction. It's a plus sign in the actual reaction. It's just written on the right-hand side. We'll look at an endothermic reaction in a few minutes, but the endothermic reactions, the delta H would be written on the reactant side. Let me write that down for you. So you see here, I wrote it for you. It says delta H is negative. The heat will be on the product side of the reaction, indicating the heat is released. But we always write it as plus heat, even though it was negative when it was written as a number outside, right here. Okay, hope that makes sense. And then if the delta H is positive, it will be, so I just paused you so you didn't have to hear me scratching, but it says the delta H is positive, and you can look on table I, and you can see all those positive delta H's. You're going to write it on the reactant side, that's the left side of the equation. And you can see the heat is to the left of this arrow. Okay? All right, I went and I grabbed table I again just so I can show you one of those. So let's look at this one right here. It has a positive delta H. And so the way I would write that would be KNO3. I'm going to leave the S off for now. I'm going to leave that little S off. And it reacts with some water, and you form K ions and NO3 nitrate ions. Okay, which side am I going to write that heat on? It's going to go on the left side of the equation. Let's do it in blue, and I'll squeeze it in here. The heat should be on the left side because it is a positive delta H. It is endothermic, and heat is entering the reaction. Okay, there's one more thing you need to know about this table I here, and again, I'll take this top reaction so that it's easy for us to all find it. When we read this reaction, and all I did was I wrote the reaction up here so that we had it. I want you to see it, and I'm going to move this out of the way so that it's out of our way. I want to show you how we would read this, right? We would say 1 mole of methane, that's methane, that's in the organic unit. I don't know if we'll get to it this year, but it's the organic unit, plus 2 moles of oxygen yield, that's the arrow, 1 mole of CO2 and 2 moles of water and 890.4 kilojoules of heat. So really, if we have 1 methane, we're going to get 890.4 kilojoules of heat. What happens if I multiplied everything by 2? So now, instead of having 1 mole of methane, I have 2 moles of methane. So if I doubled this 1 to a 2, then everything needs to be doubled. And that 2 becomes a 4, and this 890 is going to become 1,780.8 kilojoules because we doubled everything, okay? They could ask you how much heat is being released, and we know it's released because it's exothermic. The heat is on the product side over here. How much heat is released when 2 moles of methane are combusted? Combust just means it's a combustion reaction, right? So 2 moles of methane, we double everything. If they said a half of a mole of methane, so instead of having 1, we had a half, then everything would have to be divided in half. And same thing with the 890.4 would have to be divided in half. All right, so the last thing on this video is going to be this page that I found. It has some table I questions. Just want to go over a couple things with you. Down here are a series of questions. We'll start with number 1. It says draw a potential energy diagram for each reaction. I'm not going to draw each reaction, but we can draw potential energy diagrams for a few of them. The way that you're going to draw the potential energy diagrams for them is to look at this delta H. If the delta H is negative, it is an exothermic reaction. And if it is exothermic, the potential energy diagram will look like that. It will start high and end low. So all of these that are negative, and this one, that's set right there, and this one is negative, and these 2 are negative, they are all going to look like that. And this one is going to look like that. And then for the positive ones, I'll do them in red. Those positive delta H, those are going to be endothermic, and all of their graphs are going to look like this. They're going to start low and end high. I can't fit it on that side, so I'll draw it over here. So the red ones, which are positives, are going to start low and end high, meaning that they took heat in. They ended with more heat than they started with. So this is where they started, and this is where they ended. Start, end. Okay, so that takes care of number 1. Number 2 says, what is the formula for the heat of reaction? If you don't remember that, it's in the last potential energy diagram video that I did, and that is potential energy of the products minus potential energy of the reactants equals the delta H. Okay, it's always the product side, which is this side, minus the reactant side, which is this side right here. Okay? What is the sign of delta H when the heat of reactants, okay, that's the potential energy of reactants, they're calling it heat of reactants, it's the same thing, okay, heat and energy are the same. Heat of reactants is more than the heat of products. Well, if the heat of reactants is more than the heat of the products, then it is an exothermic graph, and if it is an exothermic graph, then it is going to be negative delta H. What is an exothermic reaction? An exothermic reaction is where heat is released. So heat is released. The next one says, what is the sign of delta H when the heat of reactants is less than the heat of the product? So let's look at that. Heat of reactants is less than the heat of the products. So what kind of graph is this? This is an endothermic graph. So this is endothermic, and the delta H is going to be positive in an endothermic graph. What is an endothermic reaction? Heat is absorbed. Heat is going in. And then finally, what is the pressure and temperature at which delta H is calculated for each of these? And we didn't look at that yet, but I'll grab myself a nice green highlighter, and you'll look up here and it says heat of reaction at 101.3 kilopascals and 298 Kelvin. The kilopascals is your pressure, and the 298 Kelvin is your temperature. Okay? Now you're going to get a worksheet that's going to be attached to this assignment. I want you to do the best you can with it. I know that this stuff is not easy, but hey, we're just working through it, just giving it our best shot, okay? All right, we'll talk to you soon.